In this video, we're going to round significant figures in calculations. So our objectives are to round answers to proper significant figures both in addition and subtraction and multiplication and division calculations. So what do I round my answer to is a very common question I get in class, especially when we're doing labs. And an answer that you get can never be as more precise than the least precise measurement. And I think we said that in the last video, that whichever device you use that has the least marks on it is going to limit your answers for the rest of the lab. So you have to round your answer to the least number of decimal places when you're working with addition and subtraction. So you have to look at how many decimal places you have in your initial measurements to figure out how to round your final measurement. For example, if I measure 3.75 in a cylinder, but 4.1 in a beaker, which has less marks on it, when I originally add my answer, I get 7.85. But I don't know if the second measurement has 4.10 or if it actually maybe rounded to 4.1 from 4.12. And that would change my final answer, wouldn't it? Or if it rounded to 4.1 because it was originally 4.08, that would change my answer as well. So because of that, I don't really know what that last hundredth place is. I think it might be a 5, but I can't be sure because of the second measurement. So in that case, I have to mark the 5 away. And a 5, if you know in rounding rules, anything that's a 5 and higher will round the previous number up. Anything that's a 4 and lower will round the number to same number. So that 5 has to be rejected, and the answer has to be 7.9 milliliters because it has one decimal place, just like the 4.1 number. Let's try some more examples. If I did 2.0 maybe from a beaker and 5.61 from a better cylinder, I might think I have 7.61, but like the previous answer question we did, I don't know if that 2.0 was a rounded number. I don't know if there was a hundredth place that we rounded off. So I can't keep the hundredth place in 5.61. When I got my answer, I put in my calculator, I got that, but I'm going to round to one decimal place just like the 2.0 number and get 7.6. In the next example, 5.67 plus 1.02111, there are 2 decimal places in the first number and 3 in the second number. Even though I have 3 in my answer here, I need to go to the least precise measurement, which would be 2 decimal places. The 1 will be eliminated to make 107.78. One more time that I do it with you, 23 plus 11.10 is 34.10 because the 23 was measured in something very inaccurate and has no decimal places. I can't have any in my final answer, and so I'll only have the answer of 34. So it's always the least number of decimals. So let's see if you could do it. What's a rounded answer if you had 47.1 plus 52.345? Just think for a moment. When I put in my calculator, I got 99.445, which is very precise, but I can only be precise to one decimal place. So the second 4 will only be eliminated, and I'll get 99.4. Now I want to see if you can do it. What is the answer rounded to the correct number of significant figures? 678.21 minus 45.489 is... Hopefully you've answered the question, and I'm going to give you the answer. It was 632.721 when I first put in my calculator, but because the first number had 2 decimals, I can only have 2 decimals, and therefore I just have 632.72. We're going to move on, and we're going to see if we can round. At this point, you should be able to round with adding and subtracting. So now we want to know what we do when we multiply and divide. Again, you got to go to your least precise measurement, but because multiplying and dividing is a slightly different function than adding and subtracting, we're going to a least number of sig figs, so not decimals, but overall numbers. So in an example, 13.91 times 23.3, when I first put in my calculator the number 324.103, that's a lot of significant figures. I want to make sure I'm more accurate than that. So the first number, 13.91, has 4 sig figs, and the second number, 23.3, has 3 sig figs, so I should only have a lower number, which is 3 sig figs. I'm going to round that number to 324. I'm not going to change it to like 3.24 or 32 or 3240. I'm going to keep the number around 324. I'm just rounding. So let's do some more examples. 2.0 times 35.1. When I first put in my calculator, I get 70.2. I'm gonna only go to two sig figs, and so I just get the answer 70. If you just write 70 without a decimal, it looks like 1 sig fig. The decimal traps a 0. In the next example, 5.11 times 98.654 is 504.12194. Now that's a lot of numbers. So just reevaluate that the 5.11 only has 3 sig figs, so I should only have 3 sig figs in my answer. I got 504. Last time with me doing it, 72.1 divided by 3.123. When I put in my calculator, I get this ginormous number. But in that case, if I look at 72.1 only has 3 sig figs, I should only have 3 sig figs. So I'm going to keep the 2, the 3, and the 0, but the 8 makes the 0 1, so 23.1. Actually, I lied. I have one more answer. If I was doing a calculation that had divided like this, I would still do 56 divided by 12.45, but because 56 only has 2 sig figs, I'm only going to report 2 sig figs. Together, what is an answer rounded to the correct number of sig figs? So I'm going to give you a moment to put it in your calculator and decide how many sig figs you should have and round it. Did you get a first answer that's really long and then change it to just 2 sig figs and get 15 because the 5 makes the 14 go up a little? If so, you should move on to the you do. What is the number rounded to the correct number of sig figs? Put your answer into the Edpuzzle question. When I did it, I did 32 divided by 2.01 and I got a bigger number, but 32 only has 2 sig figs, so I changed that to answer 216. At this point, you should be able to round answers using multiplication and division, and before we did it with addition and subtraction, and that's the entire video.